Today we have learned in TYBSc Electronic Science paper number first unit seconds. It is a modeling of Verilog programmings or the Verilog modules. The Verilog is the hardware descriptions language. It is the analog ports and it is widely used in the HDL, that is the hardware descriptions languages. Now these Verilog systems, it is provided for the standard system task that support from the design and specifications. Now these Verilog systems are design programming of, that is the digital hardware design, and digital for the ASCII codes and the FPGA codes. These programs, it is the keywords, that is the operations. It is display on the screen monitoring, that is the value of nets, stopping and finishings. It is done by the task of the programmings. These programs, it is the display on systems, main systems, that is the displaying values or variables, strings or expressions. These value, it is the useful to task of the Verilog systems. These display values, it is a percentage D, that is the decimal value, binary value, string, hexadecimal and the ASCII characters of the Verilog systems. Now this is the displaying parts or the display informations of the Verilog systems. Then what is the Verilog or what is the module of Verilogs? These modules, it is the main parts of the programmings, that is the modules. The modules, it is the definitions of modules in the optional list of ports to exchange any signal in an environment that there is a no port, that is considered to be as a 4-bit full adder, that is the 4-bit full adder. For examples, this is the 3 inputs full adders and the output are sum and carry. Then these inputs ports for the top of the full adders. These modules of the full adder, it is takes the input ports A, B and C and produces the output of ports, it is a sum and carry. The modules of these ports, it is a performs of the addition of for its the environment conditions. That is the these modules, it is that cannot be changed. Definitions of other modules. It allows the creation of hierarchy in the Verilog descriptions. Then next is the syntax of the modules. This is the first module names, list of the ports, semicolon, then next line input output declarations, that is the we have to select full adders, then input output declarations, that is the ABC is the input declarations and sum and carry, it is the output declarations of the programs. Then local net declarations, we have to select the nets, then write here programmings for the declarations, then parallel statements. This is there are the two statements of the full adder, like as the sum is equal to a plus b plus c, that is the a xor b xor c. This is the equations of the sum, and output equations of the carry, it is the ab plus bc plus ac. That means there are the 3 AND gate are used and 2 OR gates are used in this carry equations. There are the parallel statements, that is sum and carry. Then end modules. Now for example, we write here, that is a simple example for the AND gate, that is the module names, that is the module simple and in bracket there are the two inputs and only one outputs, that is f x, this is the inputs and y is the output. Denote here module simple and in bracket f x y bracket close semicolon, input declare here input x y semicolon output f semicolon, then assign f is equal to x and y semicolon, then end modules. This is the simple AND gates. Now second example is a two level circuits, that is there are the two values or the two outputs values we declared here, that is the module two levels in bracket a b c d f, that is the input is the a b c d, output is the f. Wire are used here, there are the t1 and t2. Assign t1 is equal to a and b semicolon, assign t2 is equal to negation of c or d semicolon, then assign is equal to t1 plus t2 semicolon and end modules. This is a two level circuit are used in the simple circuits used here. Then next is the variable data types of programmings. The variable data types of programmings, it is a variables, it belongs to one of two data types. There is a main important part of the programmings is first one is the nets. The nets, it is the continuously driven from the modules, and the connections of the programmings, it is defined to be declared, or it is the continuous or the instantaneous value of the programmings. Then second one is the register. It register value, it is to assign and store the value of the programmings. This is the data types of net data types is it is supported from right here wires, were, WAN, try, supply 0 and supply 1. Wire and try, it is the equivalent, that is there is a multiple drivers, it is driven them, and the output of the drivers are shorted together. And WOR where WN, it inserts the OR and AND gates, it is the connections of the logic gates. Then supply 0 and supply 1 models, it is a power supply connections of the net data types. Then modules using wired and ABCDF, input is declared here ABCD, output F, W and F. Then declare the main programmings, assign F is equal to A and B semicolon, assign F is equal to C or D semicolon, and end modules. Now second we write here, it is the OR gates modules using supply wires ABCF, input ABC, output F, supply 0 G ground, G and D, supply 1 VDD, that means the positive, and supply 0 ground, that is the 0 value put here. Now N NAND G1 in bracket T1 VDD comma A comma B semicolon XOR G1 G2 in bracket T2 comma C comma ground bracket close semicolon, and last is the AND gate by using AND G3 F T1 T2 semicolon, that is the end modules. Then second one is the register data types. The register data types, it is a different types of registers, it is the integer value, assign value, assignments values. These different types, that is the register integers, this is the declarations of the specified size. Register x comma y semicolon, that means the single bit register variables. Register 15 as to 0, that is this is the bus, that means 16 bit bus. It has been taken 15 MSB for the integer, it takes the default size by using the 32 bits. Synthesizer tries to determine the size of the register data types. Then The arithmetic expressions in the integers, it is treated as a 2's complement sign integers. Then the register is treated as an unsigned quantity. The general rule of the registers, it is a more actual hardware registers such as the counters, accumulator, etc. The integer, it is used for the situation of the loop counting for the register data types or the registers codings program. Then second example is the clock, using the clock reset and counter module. Simple counter clock reset RST, that means the reset and count. Input clock RST semicolon, output count. Register are used in the square bracket 31 s to 0, that means count 31 up to 0. Always at the rate post age clock begin if RST, that means the reset count, is equal to 32 s to b0 semicolon, else otherwise this condition is false, then count is equal to count 1, count plus 1 semicolon end and end module. This is the programming for register data types by using the clock, reset and counter. Then these the integers is used in the synthesis of systems, that is the data flow analysis by using the models of determine the actual size. For example, wire 1 as to 10 a comma b, integer c semicolon, then c is equal to a plus b. This is the size for the 10 bits plus carry of the programmings. Then these programmings, it is the main parts, it is the size and unsize programmings. The syntax of size and unsize programmings, for examples, 8 bit binary numbers is written here, a 0 1 1 1 0 0 1 1, that is, it is converted into decimal. It is the 1010 0010 1101. Then next is the HCX5. This is written this value in binary form. Then value is the 25. It is a sign numbers, that is the 32 bits. 1B0, that is the logic 0, and 1B1, it is the logic 1s. Then these size and unsize numbers, it is the no specified value of the programmings. This size, it gets declared from the constant itself, that is the 32 bits is nothing, it is a specified programmings. Then programs is written to the logic values, it is a main part of the logic values, that is logic 0. This is the modeling for hardwares. 0 indicates logic 0 or false conditions. 1 indicates logic 1 or true conditions. X indicates unknown value or the don't care conditions. Z is the high impedance or it is the impedance of the programmings. Then initialize this programmings, it is the uncounted of nets value to 0 Z and register variables to the X programs. Then this prefine the logic gates of the inputs value, that is 0, 1, X and 0, Z. This is the logic values of the Verilog programmings. For example, we write here the AND gate, that is the first condition, we apply the inputs 0 0, that means 0 into 0, it is the 0, that is the logic 0. Then 0 and 1, that is the 0 into 1, it is also logic 0. 1 and 1, it is a high input, that is the logic 1. 1 and x, that is the unknown, that is the don't care. We can put here the 0 as well as 1, that is the value is x. It depends on value is put 0 or 1. Then 0 and x is equal to 0, 1 and z is equal to x. That means z is the high impedance, that is the value in depends on the x. Then z and x is equal to x, that is the unknown. 0 and z and x is equal to x, that is the unknown value for these programs. It is the don't care conditions x and the high impedance z. Then it's the primitive gates of simple logic gates. The primitive gates, it is the AND gate. We can denote here output, input and input 1 and input 2. AND gate, that is the only one output and two inputs. NAND gate, it is also as the same out n1 n2. OR gate, out in n1 n2. NOR gate, XOR gate, XNOR gate, it is also same, that is the universal gates or the AND gate and AND gate. But NOT gate and the buffer gates, it is the only one output and only one inputs of the gates. Then these gates, it is the simple basic gates or the universal gates. But we have to tri-state gate, that is the tri-state gate. That means we have to put here control or the clock apply here. Then buffer 1, that is the G out in control, buffer 0 out in control, not 0 not 1 out in control, and the last one is the not 0 out in control. This is the primitive gates for the Verilog programming. Then next is the this is the primitive gates. It is the connected in simple wires, or it is also called as the nets. It is these ports or this input ports, it is connected to the nets or register data types variables. It is very important. They also can as a single output, but the number of inputs, only one single outputs and number of inputs available in these gates. It depends on these gates. Then these programmings we discussed in above. Then this is the simple Verilog programmings. Now first point is the hardware modeling issues, or the what is the hardware part of this Verilog programmings. That is the it is held on the wire, flip flop and latch. These the data types of the wire. It is during synthesis of register data types. That means it is either a wire to storage the cells on the value it is to be assigned. Now this programmings, it is written here hardware modelings. It is a module register maps to wire A B C F1 F2 semicolon input A B C semicolon output F1 F2 wire ABC semicolon register F1 F2 always at the rate A or B or C. Begin F1 is equal to negation of in bracket A and B bracket close semicolon. F2 is equal to F1 or X or C semicolon end and end module. This is the simple programming for hardware modelings programs. Then second one is the modules. It is like similar to following examples. Then next part is the Verilog operators. The Verilog operators, arithmetic operators. The arithmetic operators, it is the multiplication, division, addition, subtraction, modulus, power, and exponent. Then logically operator, first is the logical negation, logically and, or logically or. The relational operators is the less than, greater than, greater than equal to, less than equal to, equality or inequality. Then bitwise operator, bitwise negation, bitwise and, bitwise or, bitwise XOR, bitwise XNOR. Then a reduction operator, a reduction and, reduction NAND, reduction OR, reduction NOR, reduction XNOR, and reduction reduction XOR, and last one is the reduction XNOR. Then next operators is the shift operators. It is the right shift, a left shift, arithmetic right shift, or arithmetic left shift. Then next is the concatenation. This is the symbol for concatenation. Replications. This is the symbol for replications. And then next is the conditional operators. It is the three main operands used here. This is very important. Conditions, expression 1 and the expressions 2. Then arithmetic operators, that means the first one is the multiplication, that is the a value is given and b value is given. That means the multiplication of these two numbers or the two binary numbers a into b is equal to output for arithmetic multiplication gets. Then second one is the division, that means division of two numbers, addition, that is the a plus b, subtraction a minus b, and last one is the percentage, that is the two value is given, this is the percentage of these numbers. Then logically operators, that is the a and b value is given, that is a and b, or negation value, that is the a value is given, we have to find out the negation of a. Next part is the description styles in the Verilog programming. The Verilog programming, there is the two main different styles of Verilog programming. First is the data flow modeling. This is the continuous assignments, and second one is the behavioral modeling, that is procedural assignments. It is the blocking assignments or non-blocking assignments. The data flow modeling, it is the continuous assignments. The data flow modelings, the data flow modelings is the gate. It designates the chip. Increasing by rapidly, data flow modelings will become more apparent and assume great importance of the Verilog programs. It is describes to the continuous assignments, techniques, or the statements of the programs. Then this is the implicit continuous assignment statements. This is explained that this assignments delay net declarations delay for continuous assignment of the statements. It is defined to the expressions, operators, and the operands. Then this is the continuous assignments. It is continuous to the most basic statements is the data flow modeling. It is used to drive a value onto the nets. As continuous assignments, it start with the keyword assigns. That is the assign for, or it is the syntax for this is assign statements. This is the assign statements. It is the syntax for continuous statements. This continuous, it is the delay declaration delay. Then this delay can be specified the net when it is declared without putting a continuous assignments of the nets. Then nets declaration delays can also be used in the gate level modelings. These statements, it is the same effect as the following wires out. The data flow modeling, it describes the terms of expressions and the instead of primitive gates. It is the expressions, operators, and operands from the basic data flow modelings. This is the expressions, that means it is the constructs that combine operations and the operands to produce a results. Operands, it can be constant, integers, real numbers, nets, registers, times, bit select, part select, and memories or the function calls. Then operators is the operands to produce desired result of the programs. This is the example for data flow modeling of the programmings. Then next modeling is the behavior modeling. The behavior modeling, it is the significance of structural procedure always and initial conditions. This is the blocking and non-blocking procedural assignments. It describes event-based timing controls in the behavioral modeling. It also explains conditional statements by using if and else statements. Then the procedural assignments, it is the update values of registers, integer, real numbers, and time variables. These are the unlike continuous assignments of the value. It is the right hand side. It is continuously pasted onto the left hand sides of the net. Then the syntax of the procedural assignments, it is the assignments double quote variable value is equal to square bracket delay or event control square bracket close. This is the expression for the procedural assignments. Then sequential statements, it can write here. This is the begin sequential statements and if expressions right here, sequential statements else, sequential statement also written here, and the end case. Then next part is the program for or the loop for Verilog programmings. First one is the forever loop. The forever loop, it is in the initiative conditions of the programmings or the procedural assignments, and It is loop contains, that is a keywords, it is used in the specific loop, that is the sequential statements, and repeat the forever groups. Then second one is the repeat loop. The repeat loop is the construct executes the loop is a fixed number of times, and a repeat construct it must be contain the number of which can be constant or a variable or the sign value. That is the increment count from 0 to number of values we can repeat here. It is assigned to be must. Then next is the while loop. The while loop is the keyword, it is used in the specific of this loop. This loop or the while loop executes until the while expression is not true or false condition if the loop is entered when the while expression is not true. The loop is not executed at all conditions. This is the while loops of the programmings. Then last one is next is the for loop. The for loops it is a keyword that is used to the specific loop. For loop contains the three main parts: initial condition, check to see the number terminating conditions is true, or the procedural assignments to change value of the control variables of the programs. Then next one is the